Recognizing metamorphic rocks. So pressure and temperature increase with depth. So rocks melt in magma forms if temperature and pressure are high enough. But metamorphic rocks form when temperature and pressure combine to change the chemical composition, texture, and mineral composition of rocks without completely melting them or really melting them at all. Metamorphism occurs when rocks change form while remaining solid. We call this solid state transformations. Sources of temperature and pressure, we kind of talked about this before, but high temperatures come from Earth's internal heat. Could come from deep burial in the ground. You get deeper into the crust and the mantle, you get higher temperatures. That's kind of what this is showing here, the temperature increasing as our depth increases. Also nearby igneous intrusions. And an igneous intrusion is when you sort of have a plume of magma that basically comes up into, say, the crustal rock and kind of pushes its way into the rock above it. High pressures, again, come from deep burial. As you get deeper into the ground, the pressures increase. And then compression due to mountain building, and that comes from actually tectonic plates. If two tectonic plates collide with each other, then you have a lot of pressure buildup right here where they come together. And that's also where mountains are built. So metamorphic minerals. So minerals are stable at certain temperatures and crystallize from magma at different temperatures. So we kind of know this. So at different temperatures, you have different minerals that are stable. Fractional crystallization and Bowen's reaction series kind of play into this. So we talk about Bowen's reaction series, and as the temperature cools down, you get this series of minerals that are produced in a very specific order. Fractional crystallization occurs when you have some of these minerals produced and they crystallize while some of the other magma is still molten. But these same stabilities apply to minerals in solid rock as well. So if, for example, you heat up the rock enough that it doesn't totally melt, but there are certain minerals that are more stable, then those minerals will start to form in that metamorphic rock. During metamorphosis, minerals in a rock change into new minerals that are stable under the new temperature and pressure conditions. These are called solid state alterations, or we said solid state transformations earlier. Since we know the conditions required for these minerals to form, we can interpret the conditions inside the crust when the rock metamorphosed. Now, textures for metamorphic rocks, specifically foliated textures. So foliated metamorphic rocks have layers or bands of minerals. And this results from high pressure that causes flat needle-like crystals to form with their long axes perpendicular to the pressure. So if the pressure is, say, from the top and bottom here, then what you end up with is your crystals forming in this direction. So basically they're being squashed. It's like taking a piece of clay and squashing it with your hand. You apply pressure down on it, the table applies pressure back up, but flattens out perpendicular to that axis of pressure. So again, your axis of pressure in this case would be this way, so up and down. So then perpendicular to that would be sort of side to side. So you get these needle-like crystals that form these bands that kind of spread out in these directions. Non-foliated metamorphic rocks. These are composed mainly of minerals that form with blocky crystal shapes. So some examples. Quartzite is an example formed by the metamorphism of quartz-rich sandstone. So if you have sandstone, which is a sedimentary rock, you heat it, apply some pressure to it, and it metamorphosizes, you end up with quartzite. Marble is an example formed from the metamorphism of limestone or dolomite. Some have smooth textures formed by interlocking grains of calcite. Marble is often used in sculptures and construction, etc. So these are non-foliated metamorphic rocks. One thing that does make these kind of stand out is they tend to be shiny. Okay, not necessarily metallic, but they tend to have sort of a shiny surface to them, almost kind of glass-like. And then porphyroblasts. So under certain conditions, new metamorphic minerals can grow quite large while the surrounding minerals remain small. These large crystals are called porphyroblasts. They can range in size from a few millimeters to a few centimeters. Okay, so they could actually be quite large. But like here's a penny, so here's some actual garnets in this schist that are actually rather large here. So these resemble the large crystals formed in pegmatite granite, although they're not pegmatites. Porphyroblasts form through the rearrangement of atoms during metamorphism or metamorphosis instead of from magma. Okay, so garnet is actually a very common porphyroblast, which is actually what all of these are over here, are garnets. And then this table could be used for the identification of metamorphic rocks. So you kind of start on the left side here. Okay, so you start by looking at the rock and decide, is it foliated or is it non-foliated? First thing you kind of want to look at is it kind of shiny, which kind of tells you that there's a good chance that it's going to be a metamorphic rock. But then you look at it, is it foliated, is it non-foliated? Then you decide, if it is foliated, well, does it have layers? Is it just made of nice flat layers? Or is it banded? And banded kind of means you have light and dark areas. So you may have like a darker area and then a lighter area and then a darker area and a lighter area, etc. So that would be a banded foliated metamorphic rock. Then you decide the texture. So is it fine grained? Is it medium to fine grained? Is it coarse grained, etc.? And then from there, you can kind of figure out what it is. You could look at the minerals in here, but you don't really need to necessarily. So if it's layered, for example, and it's fine grained, it's probably slate. If it's layered and coarse grained, it's probably schist. If it's banded, if it has these light and dark patterns, it's called gneiss. If it's non-foliated, really your options are quartzite or marble.